LangGraph's message handling mechanism employs a conflict resolution strategy for message updates, where identical identifiers trigger content replacement rather than concatenation. This approach ensures message state consistency by treating the identifier as a primary key in the message collection. We will be examining how message lists are initialized with unique identifiers, and how the add messages operation resolves conflicts by overwriting existing entries when duplicate identifiers are encountered. The upcoming code demonstrates this behavior through a simple sequence of message creation and combination.
MSGS1 equals human message content equals hello. ID equals 1. MSGS2 equals human message content equals hello again. ID equals 1. Add message mx1, MSGS2. Hash human message content equals hello again. ID equals 1.
This code demonstrates message deduplication based on message IDs in LangChain. The add messages function merges two message lists, but when messages share the same ID, only the newer message is retained. In this case, both MSGS1 and MSGS2 contain messages with ID 1, so the resulting list contains only the second message, hello again. The pattern shows how LangChain handles message conflicts by prioritizing the most recent message when IDs collide. This behavior is useful for maintaining conversation state, where you might receive updated versions of the same message. However, it also means older messages with the same ID are silently discarded, which could lead to data loss if not handled carefully. The approach assumes that message IDs are unique identifiers for logical messages, not just sequential markers. Let's break it down line by line.
MSGS1 equals human message content equals hello. ID equals 1.
Creates a list named MSGS1 containing a single human message object with the content hello and an ID of 1. This establishes a message collection where each item represents a human-generated communication, uniquely identified for tracking or reference.
MSGS2 equals human message content equals hello again. ID equals 1.
Creates a list named MSGS2 containing a single human message object with the content hello again and an ID of 1. This represents a user message in a conversation flow, where the message content and unique identifier are explicitly set.
Add message mx1, MSGS2.
Calls the add messages function with two arguments, MSGS1 and MSGS2. This combines the two message collections into a single collection, likely concatenating or merging them in some way. The exact merging behavior depends on the function's implementation, but the immediate effect is that both message sets are passed for processing. LangGraph's message handling employs a primary key conflict resolution strategy where message IDs act as unique identifiers. When add messages merges collections, duplicate IDs trigger replacement rather than concatenation, ensuring state consistency by always preserving the most recent version. This behavior is demonstrated through the simple case, where two human message objects sharing ID 1 result in only the newer message being retained. The pattern assumes IDs represent logical message identity rather than sequential markers, which is powerful for maintaining conversation state, but requires careful handling to avoid unintended data loss from silent overwrites. The core insight is that message IDs aren't just metadata. They're the mechanism enforcing consistency in message state management.
The message list devours its history, but spits back only the last human message. A digital ouroboros with amnesia.